Okay, now let us look at these questions. The expression of a standing wave is given by y equal to 0.3 cosine 0.5 pi x and then sine 60 pi t. Okay, where y and x are in meters and t in second. So always pay attention to the unit. This one is meter, t is in second. This one is meter, this one is second. Unlike last time, the previous question, our y and x are in centimeter. Our y and x in centimeter. This time, our y and x are in meters. And then time in second. So be careful. Be careful. This time, all the amplitude, all the wavelength, all in meters. Last time is in centimeter. This time in meter. Okay. Now this is the formula for standing wave. A standing wave. So we rewrite this formula, and then I want to compare with the general formula. So this is y equal to 0.3 cosine 0.5 pi x, then sine 60 pi t. Yeah, make some bracket here. Okay. Relate to the general formula. General formula of standing wave is 2a cos kx sine omega t. Okay. Y equal to 2a cosine kx and then sine omega t. Well, here 2a actually sometimes we just write as a, just write as a, yeah, a total, because you know why? This is this a here is actually amplitude for the individual wave, yeah. So total is 2a. Or you just write as a total, sometimes, yeah. Okay, so from here we can compare and relate. 0.3 is 2a. Okay. Actually amplitude for individual wave is just 0.15 meter. Okay. And then okay, and then here you have the k, yeah, cos kx. This is the k. And this is the omega 60 pi, yeah, with the t. Okay, so k is 0.5 pi, and then omega is 60 pi. And then write the unit. The unit of y is in meter, so x is in meter also, and then time is in second. So what I can say is here the maximum amplitude 0.3 is also in meter because it follows the displacement. This one in meter also. Okay, and then the x is in meter, so the k, the wave number, also in per meter. And then time is in seconds, so the omega is per second. Okay, so now all the unit is in meter. Okay. So now I want you to write the expression for two progressive waves forming the standing wave above. So how? So how do you do? What you do is question A. So write the two formula. Okay. So the two formula is just this is actually the y. I can write as this is actually the y total, yeah, the total displacement. This is the total displacement. Okay, can write as y total. So for individual wave is small y. is small y, because we know that okay, we have y1 and y2, y1 and then also y2, because we all know that the standing wave is the superposition or overlapping between y1 and y2 waves. These two waves overlap or superimpose, superposition, and then you get the standing wave equations. Okay, 2a cos kx sin omega t. Okay, so for individual wave, it's just an a lah. It's just an a. Okay, just an a. So the a now divide by 2. Okay, and this is the just a. And then the formula is sine omega t kx. One is minus kx. Another one is omega t plus kx. Okay, plus kx. So these two formula. Right. Okay. So this is the two formula. Okay. This one is the first one is wave. You have negative. They just differ by the direction. You see, negative kx means the wave is this is the first wave lah. This is the first wave. Yeah, with amplitude A. Okay. This is the first wave. The first wave, which is moving to the right. Which is moving to the right because negative kx moving to the right. The first wave. Let me draw it properly. Okay. And then the second wave. The second wave is wave moving to the left. Wave moving to the left. Okay. This is a wave moving to the left. Moving to the left is positive kx. Okay. This is the amplitude A. So when these two superpose, overlap, you get a big wave, which is the standing wave. You get a standing wave, which is 2a, 2a from here to here. Okay, 2a. This is the standing wave. This is this one is just now. This one is the y1. This is the y2, and this is the this one is the y total. Overlap. This is the y. This is the y total. Okay. That's why it's 2a. Individual is just a. Yang moving to the right is negative kx. Going to the left is positive kx. Okay, so these are the two equations. So now, what is the a? A you just divide by 2 because we know that 2a is 0.3 meter. Remember, the 2a is in meter because it follow the y. The y is in meter, so 2a also in meter. So what is the value of 1a? Value of 1a is 0.15 meter divided by 2, 0.15. So this the y1 is 0.15 meter. Okay, 0.15 meter. Then sine. Okay, and then the standing wave is 0.3, so individual wave is 0.15 divide by 2. Divide by 2. Omega. So what's the omega? Omega we find from here. This is the omega 60 pi. With the t. So this is 60 pi t. I think I need to rewrite this further a bit over here. Okay, good. And then This is negative k. What is the k? K is 0.5 pi. 0.5 pi. Okay, pi x. That's it. Then what's the next formula? The next formula, y2, the second wave, the amplitude is also just 0.15 meter, and then sine omega is 60 pi. It's the same with the standing wave there. See that? And then this is a plus k. What's the k? 0.15 x. So this is the second formula. So you see, what's the difference between the first formula and second formula? The formula for the displacement, progressive wave, they just differ by the direction of propagation. This one is moving to the right, this one is moving to the left. They just differ by the direction. The amplitude, the period, the frequency, and the wavelength, all the same. They just differ by the direction, positive or negative kx only. Okay? And you must also write the unit. Don't just give the equation without unit. Okay? So the y and x are in meter. You must write this. The first equation and also the second equation here. Equation must couple with unit. Okay? It's the same with the standing wave. Meter and second, and meter and second. Remember, this one is y and x, not just y. Not just x. It's y and x. Okay? Follow this one. So you must write the unit. Also. So these are the two equations. Okay, y1 and y2. They are correct. Y1 and y2. See that? All the structure is almost the same. Just this one 2a become 1a, 0.15. And then the omega still the same, 60 pi. The k 0.5 pi. K, the k 0.5 pi. Kx. And then just differ by positive, negative. There is a direction of the wave. Opposite direction of wave. One to the right, and then positive kx is to the left. Okay, so these are the two formula. So now this is what it means by expression. And this is what it means by expression. Means you want equation. Okay, so next of the progressive wave. Equation for progressive wave, not the standing wave, the progressive individual wave. So now, find the wavelength. I want to find the wavelength, frequency, amplitude, velocity for both progressive waves. So this v is not particle velocity, it's the wave velocity. Very simple. So now do the question B. So how to find the wavelength? Wavelength we can find from where? Wavelength we can find from k, wave number. Our k is 0.5 pi. What's the unit? You must check the unit. So k have to relate to the x. K have to relate to the x, and x unit given in x are in meters. X are in meter. So our k is per meter. Our k is per meter, not per cm. Is per meter. So you must be careful with the unit. Must be careful with the unit. Is per meter. So next, what's the formula for our wave for our k? Our k is 2 pi over lambda. 2 pi over lambda, wave number. 2 pi over lambda. So substitute. We can cancel the pi. And we get the wavelength. What's the wavelength? So what's the wavelength? 2 divided by 0.5. Okay, I got 4. This one unit, what's a unit? Meter, because our K is per meter, so our wavelength need to be meter, not centimeter, is meter. Because it also follow our X is in meter, so our wavelength need to be in meter. Be careful, yeah. So that's correct, yeah. Is the answer correct? Yes, 4 meter, that's correct. Next is our frequency. We want to find frequency. We find from our omega. Omega is 60 pi. Yeah, let's do it. Okay, sorry. So we got our omega. Our omega is 60 pi. What's the unit? Check the unit. What's the unit? Our omega is per second because the time is in second. Time is in second, not millisecond, is second. So our omega also per second. You must write the unit. Don't just write the value without unit. Unit is important. If you get the unit wrongly, you lost mark for your answer. Omega, we want to find frequency, isn't it? So omega we change to 2 pi f, 2 pi frequency. 2 pi frequency is equal to 60 pi. So I can cut off the pi. And what's the frequency? 60 divided by 2, which is 30. Also per second. Or we can change it to per second is hertz. Okay. That's it. So is the answer correct? 30 hertz. Yes, 30 hertz is correct. 30 hertz. Yes. Okay. So now want to find the amplitude. So what's the amplitude? Okay. What's the amplitude? Our amplitude is equal to amplitude for what? For progressive wave. Amplitude for progressive wave, that means a smaller wave, not the big wave. This standing wave is the maximum amplitude for standing wave. But for progressive wave is only is 0.3 divided by 2. Okay. So yeah, as given is this one is 2a. 0.3 is considered 2a. Actually I write already here. Just copy this one lah. Just drag to here. Okay, so we got our amplitude for progressive wave. This is the answer. Is it correct? Yes, 0.15 meter. The unit is in meter because it follow the displacement meter. The y is the meter, so our 2a also in meter. Okay, not centimeter. Remember, 2a is for standing wave, the maximum amplitude for standing wave, and a is for progressive wave. The individual. You have two of them. Okay. The individual progressive wave is 0.15 only. For standing wave, after combined superposition, you get 0.3, which is multiply 2. Okay. So 0.15. The question one is progressive wave, amplitude for progressive wave, which is a smaller amplitude. Okay, so 0.15, that's correct. 0.15. Next is I want to find the wave speed, the velocity of both progressive wave. So very easy. Just use these two, the lambda and the lambda and the frequency. You can find your wave speed. Wave speed of the progressive wave, v equal to f lambda. V equal to f lambda. We got the lambda already, we got the f already, all in SI unit. Remember, check all in SI unit before you do further calculation, or in SI unit. So substitute. Our frequency is 30 hertz, or 30 per second, and then our wavelength is in meter. So what's the answer? 4 times 3 is 12. So 120. Unit is meter per second. So it's easy if you write the unit already. So it's not centimeter per second, it's meter per second, because all this while we are using meter only. So you see, very easy, right? Is it correct? 120 meter per second. Yes, it's correct. 120 meter per second. That's correct. That's correct. Okay. That means it's 4 times 30. It's 120. Okay, so that's all for these questions. Very simple questions. Okay, bye.